Hello and welcome to this video on differentiation and the chain rule. Now when we're differentiating functions where the variable appears by itself, as in these functions on the top row, that's quite easy as we just use the power rule. For example, y equals square root of 2x dy by dx. That becomes x to the minus half. For w to the power 50, that becomes 50 w to the 49. For the et, when we differentiate that, that becomes e to the power t. Tan x, that becomes sec squared x. Now, the difficulty arises when we have another function as well. So basically we have a function within a function, or a nest of functions. So here we have a function w squared plus 3w, and then another function which is to the power 50. So that becomes a function within that power function. Now let's have a look how we can tackle this if this nest of functions is quite simple. So for example, where we have f of x equals x squared plus 2x all squared. So what can we do? Well, we can expand. So we have x squared plus 2x times x squared plus 2x. And when we use our FOIL method, or as I call it, the claw method, we get so multiplying out, following these arrows, we get x to the power 4 plus 4x cubed plus 4x squared, and dy by dx equals, bring the power down and then reduce the power by 1. So that's 4x to the power 3 plus 12x to the power 2 plus 8x. When we can't do this, say that power was a 10, we can't multiply out 10 times, then we need another rule. And this rule for this nest of function, or as sometimes called the function of a function, if we put it into words, the rule is this: the derivative of the outside function, then we leave the inside alone, multiplied by the derivative of the inside function. So what do we mean by that? Well, let's take this top one again, for example. X squared plus 2x all squared. This is the inside, and this is the outside. So what do we do here? Well, we multiply, or we get the derivative rather, of the inside function, which is this one, and we multiply it by the outside function, leaving the inside alone. So let's do that then. So the outside function was the derivative is 2 multiplied by whatever's on the inside, and then we multiply that by, so we leave the inside as it is, we don't do anything to that, and then we multiply by the derivative of the inside function. So the inside was that, and the derivative of that becomes 2x plus 2. So this then becomes 2, the inside was x squared plus 2x, and then 2x plus 2, and that is the derivative. If we multiply that out, then we get 4x cubed plus 12x squared plus 8x, which is the same as the above. Another way of looking at the chain rule for derivatives is to take y equals u to the power 5 and u to equal 4x cubed plus 4x squared. So y is in fact 4x cubed plus 4x squared all to the power 5. When we do this, then this is the chain rule. dy by dx equals dy by du multiplied by du by dx. And this is known as the chain rule. So how can we use the chain rule with this function? So what we do is write out the function y equals 4x cubed plus 4x squared all to the power 5. Identify the u, and the u is usually the thing in the bracket, which is 4x cubed plus 4x squared. So the y then becomes u to the power 5. Now using these, we have dy by dx, using the chain rule, dy by du, which is 5u to the power 4. When we take the derivative of u to the power 5, that becomes 5u to the power 4. Bring the 5 down, take 1 off the power, so that's 5 minus 1 is 4, and then we multiply that by du by dx, which is u prime. This then becomes 5, and now we're going to put the u back, which is 4x to the power 3 plus 4x to the power 2 all to the power 4, and multiply by u prime, and u prime is the derivative of this function, which becomes 12x to the power 2 plus 8x, and that is the derivative using the chain rule. Okay, let's go over a few examples of the chain rule and its application. So y equals sine of x. Again, we have a function, sine of x, within another function, which is the square root. So we have to apply the chain rule. U equals sine of x, and then y equals square root of u, or u to the power half. Applying the chain rule, dy by dx. So first of all, we have dy by du, which is a half u to the minus a half, and then we multiply that by u prime. Now this equals a half sine x, which remains the same, to the minus a half. So this is this term, and we multiply that by u prime, and u prime is, when we differentiate sine of x, we get cos x. And that is the answer. So, and if you want to tidy that up, that becomes cos x all over 2 square root sine x. Now if we have y equals sine the log of x, the log of x is nested within the sine function. So here we have a nest of functions, or a function within a function. Again, let's write down our u, let's write down our y. So the u is log of x, y is sine of u, dy by dx. So we want dy by du. So dy by du we differentiate, and when we differentiate sine u we get cos u, and multiply that by u prime, which is du by dx. So this is the chain rule. Replacing the u's, we get cos log of x multiplied by, when we differentiate log x to get u prime, we get 1 over x. And this becomes dy by dx equals cos log of x all over x. U equals whatever's under the root sign or in a bracket, 3x squared minus 4. Y equals square root of u, or u to the power half. To apply the chain rule, dy by dx. So we have dy by du as half u to the minus half. And we multiply that by u prime. Replacing the u's, we have half, and the u was 3x squared minus 4, and we have minus a half as a power, multiplied by u prime, and the u prime, when we differentiate 3x squared minus 4, bring the 2 down, that becomes 6x, 2 minus 1 is x, so that's 6x. If we want to rearrange that, half times 6x, 3x, and because it's a minus, all over half means square root 3x squared minus 4. When we're looking at powers of e, if you remember, when we differentiate e to the x, we get back e to the x. Remembering that rule, so u equals t squared, y equals e to the u, dy by dx. Let's apply the chain rule. So we want dy by du. So dy by du becomes or stays e to the u multiplied by du by dx, and if we differentiate t to the power 2, we get u prime, which is 2t, and e to the power t2. Let's have a look at another function. U equals x to the minus 4 plus x to the 4. Y equals the natural log of u. So dy by dx, differentiate y with respect to u, dy by du, we get 1 over u, multiply that by u prime. So if we replace all the u's now, so we get 1 all over x to the minus 4 plus x to the 4th, multiplied by u prime, and u prime, when we multiply it, u prime when we differentiate becomes, bring the minus 4 down, minus 4, x minus 4 minus 1 becomes minus 5, plus, bring the 4 down, 4x, and that is the answer. In this next example, this function y equals sec 1 minus 5x in brackets. So here we have a function and we want that function within that function, so it's a nested function, so again we need to apply the chain rule. Now let's remember what happens when we differentiate. Let's put this in a little bubble. When we differentiate sec x, we get sec x tan x. So similarly, when we differentiate sec u, we will get sec u tan u. So let's do our little u equals and y equals. So u equals whatever's in the brackets, 1 minus 5x. Y equals sec u. Dy by dx equals, so we want the dy by du, so differentiating here we get sec u tan u multiplied by u prime. So when we now replace the u's, we get sec 1 minus 5x times tan 1 minus 5x, and all that is multiplied by u prime. When we differentiate this function, we get 5. So the answer is sec 1 minus 5x multiplied by tan 1 minus 5x times 5. Okay, let's have a look at something a little bit more complicated. Again, we have a function sine tan x and a square root, so that is a function within a function. But when we look at sine tan x, that itself is a function of a function. So in this case, we need to apply the chain rule twice. So let's start with this function. So we have u equals sine tan x. and y equals square root of u, which is u to the half. When we apply the chain rule, dy by dx, we have half u to the minus half multiplied by u prime. Now u prime itself, we need to apply the chain rule, so let's do that over here. So we have u equals y equals, so in this case u is sine tan x, u is tan x rather. No, let's figure out which is the u. So we want to make that into sine u. Let's do the y first, so sine u, don't get confused. And then our u becomes tan x. So dy by du. So we have the integral of sine u, which is cos u, by u prime, and this becomes, when we replace it, cos of u, which is tan x, and u prime is the derivative of tan x, which is sec squared x. So now we know this u prime, so we can go back and replace our u's in here. So this becomes a half, and our original u was sine x tan x, or sine tan x, multiplied by our u, u prime, which is cos tan x sec squared x. So this comes up here. So when we simplify, this becomes 1 over dy by dx, to the minus we get a 1 over the half, we get a square root sine tan x multiplied by this derivative we got over here, which was cos tan x sec squared x, and that is our answer. In this example, we're not given y in terms of x, we're given x separately, and we still want to apply the chain rule. So let's write down the chain rule to begin with. Dy over dx equals dy over dt multiplied by dt over dx. So that's the chain rule, and we want to apply this in this case. So from here we can get dy by dt, and from here we can get dx by dt by differentiation. But we need dt by dx, so we'll come back to that in a minute. Now let's first of all do the dy by dt. In this case, u equals 1 minus t squared, and y equals u to the minus half. When differentiating, then dy by dt becomes minus u minus half u to the minus 3 over 2, and then we want u prime, so that becomes minus half u to the minus 3 over 2 multiplied by u prime, which is over there, which is minus 2t. Bring the 2 down, that's minus 2, and then the t. Minus 2t. Put that in brackets so we don't get confused. So dy by dt becomes, when we tally that up, t minus half times 2t is t, all over the cube root of 1 minus t squared. Now we want to find dt by dx. For this we need another rule, and the rule that we have to remember is dy over dx equals 1 over dx dy. So this is another important rule that we have to remember. So if we have dx by dy, if we find the reciprocal of it, that's dy by dx. So in this case, from this equation, or this function, we can get dx by dt. So let's do that over here. So dx by dt is minus 6t, and dt by dx is the reciprocal using this rule, which is minus 1 over 6t. Now we multiply the dy by dt by the dt by dx, and what do we get? We get dy by dx is minus t 6t cubed 1 minus t squared, and if we tidy that up, that becomes minus 1 over 6 1 minus t 3 over 2. A couple of important rules when differentiating trig functions. If we have y equals sine ax plus b, and then we want to differentiate that using our chain rule, we let u equal ax plus b and y equals sine u. Then dy by dx becomes cos u a, which is a cos, and then the u was ax plus b. And this result is very important in integration as well, when we do the reverse of differentiation. But this rule applied to some other functions, say d by dx, cos a plus b, ax plus b, and that becomes minus a sine, and then what's in the brackets remains the same. And similarly, d by dx tan sec squared ax plus b. So these are some very important rules when differentiating trig functions. So if we take an example, cos 3x minus 1, when we differentiate, that becomes minus 3 sine 3x minus 1. Another important rule when considering trig functions, if we have cos power 4 to the t, that means cos t to the 4. We can put brackets around that. So some brackets. So u is cos t, what's in the brackets, and y equals u to the 4. When we do the integration, the differentiation rather, we get dy by dx equals 4u to the 3 divided by u prime, which is 4 cos 3t, and we'll multiply that by minus sine t. Similarly, if we have cos, and then we have t to the 4, u equals t to the 4, and y equals cos u. So bear this in mind when considering trig functions to a power.